Hello everyone, welcome back to my channel. In today's video, I will be showing you another industrial automation project that I have developed using Siemens TIA Portal. This project demonstrates how to control a 21 kilowatts motor along with 3 auxiliary pumps, including cooling, lubrication, and hydraulic pumps. I have implemented the complete ladder logic and designed a basic HMI screen to monitor the system. Let's take a look at how the entire process works. This project includes 21 kilowatts main motor, cooling pump, lubrication pump, hydraulic pump, analog temperature sensor, fault switch, used for simulation, temperature input values, used for simulation, PLC ladder logic in TIA Portal, basic HMI screen. Let me explain the operation step by step. Step 1, starting the system. When the system is started, cooling pump turns on, lubrication pump turns on, hydraulic pump turns on. All 3 pumps must run for 10 seconds before the main motor can start. After the 10-second delay, the 21 kilowatts motor automatically starts. This ensures the motor has sufficient cooling, lubrication, and hydraulic pressure before operation, just like a real industrial machine. Step 2, fault handling of the 21 kilowatts motor. If a fault occurs in the main motor, the 21 kilowatts motor stops immediately. The 3 auxiliary pumps continue running for 10 seconds. After 10 seconds, all pumps turn off. This delay prevents sudden pressure drops and protects the mechanical system. Step 3, temperature monitoring system. The system includes an analog temperature sensor connected to the 21 kilowatts motor. I used simulated values to represent real temperatures. When I enter 17,000 in the analog value, it represents around 61 degrees Celsius. When I enter 25,000, it represents around 90 degrees Celsius. Now, here's the logic. In my simulation, I triggered the fault using a switch, which helped demonstrate the full fault sequence inside TIA Portal. When temperature greater than 60 degrees Celsius, an alarm indicator turns on in the HMI. This warns the operator that the motor is getting too hot. When temperature greater than 70 degrees Celsius, the entire system shuts down immediately. Main motor stops. All pumps stop. Alarm remains active. This is a safety trip to prevent damage to the motor due to overheating. This type of system is commonly used in heavy motors and compressors, industrial gearboxes, hydraulic power units, cooling and lubrication systems, high-power industrial machines. So this is how I implemented a complete motor control system with safety features using TIA Portal.